Hi there, guys. Today we're going to talk about getting your Arduino to communicate with, well, in our case, I've set up a couple of examples using Unity 3D, but also you could use Visual Studio or anything. Point is, in my tutorials, we're primarily working with C# and C++. There's a bit of difference between these. My setup is a Arduino Uno. I got a wire from A0 to a transistor, and that transistor leads out to a LED and a small resistor. And the reason I'm using a transistor is because I found powering things through my analog out is not really working. It's at least not working very well. So I'm powering the breadboard through 5 volts and ground, of course, and then I'm pulling the power through the transistor instead of A0. And I'm actually quite happy with that and how it works. Certainly a lot better than what we did before. So let's first check the code I use on my Arduino. First of all, we're going to initialize and we're going to define an integer called incoming byte in an array. And you can see I've used 2. It actually means 3 because we're also counting 0. That's because I'm sending 2 bytes from Unity to my Arduino, and it should automatically send a third that is a end line or end signal. You know how in old cowboy movies there's a guy working the radio, or I'm not sure what you call it, but it's a Morse code, and they would always end with stop. So they would end the line with stop. Well, modern computers do the same. So that's why we're reserving a byte for the stop signal. Then I'm going to set an integer for A0. That's just the LED pin. I got a boolean. The boolean is just whether the light is on or off. From the beginning, we're setting it to false. Then we have our main setup right here, or void setup. And we're just setting the pin mode for the LED to output. We're going to write instantly digital write low to the same pin, so we are sure it's off. In case for some unknown reason it should be on, but just better safe than sorry. Then I'm initializing a serial connection to the computer at the baud rate of 19,200. And the reason for that is I'm not sure why. But when I use 9600 like usually, I've found it's not working. My Windows software, the programs I write myself, won't talk to the Arduino. They won't be able to communicate for some inexplicable reason. So 19,200, it works. It works from my Android phone and it works from my PC. Well, sorry about that. Just had a computer crash. Well, that happens. Anyway, let's go back to the code. We were at our void loop. We just finished setup. So before I start this void loop, let's just check this function I have right here at the bottom. I'm really sorry. I can't really zoom this part because, I don't know. Anyway, down here it says void LED check. And what it does is just a small function checking if LED, the boolean we set up here, if it's true, then set the LED pin to high. If it's false, turn the LED off. That's all it does. And because we're going to use that right here in our void loop, it's just going to run over and over and over. Check, 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 check constantly. If the LED is on or off, or sorry, if the LED setting is on or off, or true or false. So main loop, first thing we do is check if there is any serial data available. That's what it says right here. Serial data means, is there something in the buffer? If there's something in the buffer larger than 0, then run this entire thing. First thing we do in this thing is look for the letter L. That's what this is. While serial.peak equals L, capital L, means we're just going to look through all the serial data, all the bytes, to check is there something like a capital letter L. If there is, then we're going to continue to read the next letter right after the L, and we're going to store it in our array as 0. So we're going to pass the byte as a number. So we're going to store it as a number. So then we're going to check, is this number equal to 1? If it's 1, then we're going to set our boolean from the beginning to true. Any other number or letter or whatever, it's going to be false. So in order for this, everything to work out and everything to be true, we need to send 2 letters to our Arduino. We need to send the capital letter L and the number 1 right after the L. Then it will turn on. Anything else would just turn it off. However, if it is unable to find the L back here, then it's just going right down to this function, and it's going to clear the rest of the data, so it's able to get new data from somewhere. So that's the Arduino being hooked up, and as you can see, it's right here. Let's make it a bit bigger. There we go. And you can see the LED right there. So this Arduino already has this program on it. So let's open the serial monitor. It's right there next to my screen. Let's see if I can buy it right there. And what you need to pay attention is this LED. So I'm going to write capital L1, and it turned on. Capital L. Anything else, it turns off. If I write just once, nothing, one, nothing, anything, nothing, it's only going to work with a capital L and the following 1. Then it turns on, as you can see. That's cool. Okay, now we know that works. Let's close the serial monitor. Let's minimize me a bit. Let's close the Arduino IDE. I'm going to open a small program. Where is it? Right here on my desktop. There we go. It's called Putty. I'm sure some of you know it, some of you don't. It's just a small program where you can use it to communicate with Telnet objects like your router and other computers. You can use it as we're going to right now is a serial connection. So I click serial, I hit COM4, and I'm going to need to set the correct baud speed. So 19,200 and open. It's going to open this black box. Excuse me. So what I want to know now is this program able to send my Arduino a signal to turn this LED on or off? If it is, then everything should work. So let's type big L and 1. Notice this program does not type output to the screen when you type input. So hit enter, nothing. There we go, L1, and it turned on. Oh, maybe you can't see. So you can see I'm going to type L0, it's off, L1, and it's on. Off. Okay. Perfect. I'm going to close Putty. It's going to give me an error. Are you sure you want to close the connection? Yes. Okay, now I know from experience, Putty did not close my connection to the Arduino. So I'm going to unplug my Arduino and replug it. That's just how it is. Now for some Unity examples. Let's do this. Yes. Let's minimize me a bit. Let's do something like this and put me up there in the corner. I got Unity set up right here. And yeah, I know it's Unity Pro, but that does not matter. You can use any version of Unity. Or if you want, you can do the same thing using Visual Studio, which is free. So just download it. Unity 3D is also free. Go ahead. Have fun. Very nice cup of coffee. So, done downloading? Good. Now I got 3 examples running right here. One example, we're just going to run it from the console. As you can see, we got this console in Unity. No visual effect, whatever. Then I got a 3D example and using Playmaker, if anybody is using Playmaker. And I got an example using NGUI. I'm not very happy with the built-in standard UI, and I know Unity 4.6 has its own fucking GUI, but I've been using NGUI for a couple of years now, and it's just, well, I'm not going to work with a new GUI. So, yeah, exactly. The first one, I'm using this one called LED Debug, and I just click it so we can see the code. I love monodevelop because we can zoom. It's really nice on the camera. This is the entire code. It's just like Arduino IDE. So you can see we got this start void, we got this update void, and I got a function right here I wrote. So it's sort of like the setup and the loop. And you might want to think this update as your loop, except this update is run once per frame. Meaning if you're running 30 frames per second, it's 30 times this is going to try to run. That's something you need to know, and there's a lot of frame control available in Unity, even though most developers don't use it. It's there, and that's just nice to know if you want to work with something that involves time, like frames per second. We're going to look at this line today. It's called serial port my data. That's just a reference to me, so I can remember it when I'm going to reference this. Equals new serial port, and I'm going to define which COM port and the speed. And I forgot one thing. Line number 3 we got right here. You need to include this, so start by typing using system IO ports, because you're telling Unity, we're going to talk to serial connections now. So we're going to include the library for ports, just like you do in Arduino. You sometimes include a library for something else. Windows works similar. So we're going to include the ports library. Okay. We defined a connection. This is not something we need. It's just something I used to make it able to show all the COM ports listed in the console, because I can't see them when I don't have the Arduino IDE open, and I don't like the device manager. I like to have them shown because things might change on the fly. So it's just going to print a list of COM ports available right now. And then I'm going to call the function called LED on. LED on is down here, and it's very important to note it's called a public void LED on. Public because it's going to be accessible from any part of your Unity program. So if you're making a game or something that's going to access your scripts, you need to make sure your functions are public, and I'll show you in a minute why. For this instance, it's not important at all. So we're just going to leave it on. First line, my data, reference this point up here, dot open, means we're going to open the connection now. We're going to skip this line. The debug log is just going to write in the console on screen for me what's going on. Then we're going to write line. That's similar to print line in Arduino. You know, print ln, same thing, except this time we're sending it to the serial port, and we're sending L1. And then we're closing the connection. that's it. It's always good to close the connection. So I got an example where we're going to use this. As you can see on my scene, I have my camera. And there's no objects in game, so no reason for that. And I got a empty game object. Let's move this guy over. You can see there's nothing attached. It's even zeroed in at 0, so it's just nothing. I'm going to hit play, and nothing happens because there's nothing in the scene. However, okay, let's see. Let's do this. There we go. LED is right there. And I'm going to take this LED debug and drag it right over to this thing. And if you notice, it turned on. That's because in Unity you can run a script live by dragging it onto a scene or onto a game object. And that's what we did here. We just dragged our debug script right onto this empty game object. And it worked. It turned the LED on. I'm just going to hit reset on the Arduino. Excuse me. And I'd like to show you another example. So my second example is going to be, let's see. Okay, sorry about that. It's going to be this one called one NGUI. And let's move this guy down. Yeah, where can we put him? I actually think I'm going to put him up there. The webcam is very important because we're going to watch the LED. But basically, I got a scene. It's just this menu. And if you work with NGUI, you should recognize that it's very simple. It's just a sprite with a sprite and another sprite and 2 buttons. The thing is, and this is why the public void is very important. I got my button right here, my on button, and I got my off button. And you can see I got this script down here. It's called LED object. Well, basically, I got a script attached to this button. Not the label, but directly on the button. And the script is this one. Let's take a look at the code. It's a bit different, but only very, very little. As you can see, I commented out the list of COM ports, but instead I have this public void LED on, and I got this one public void LED off. They're exactly the same like all the rest we talked about today, except this one has L1 in it. This one has L0, meaning that's the items Arduino, the Arduino in this case, is looking for. Then I defined my buttons using NGUI, and I simply dragged my script onto the inspector over here, and it appears down here, and you can see, you can select it. It even gets this this thing. I'll show you again what I did. I created an empty game object, and this object I'm going to call LED Fun. That's it. I'm going to take my LED switch and drag it onto my LED Fun thing. Then I click my on button, and you can see it has this thing here called on click. So I expand that, then I pull my LED Fun right on top of there, so you can see it's right there. And then I say method, and I can simply select which function I want to run from within my script because they are public. So in this case, it's on, meaning when I hit on, it's going to run the on script. Time for a demo. So I'm going to increase the webcam, hit play, wait for it to load. There we go. I hit on, it turns on. I hit off, it turns off. On, off, on, off. That means I can now develop a GUI for something very easily in Unity. And with this knowledge means we can build something in Unity for our mobile devices and make them send signals to our Arduinos through serial connections. And I'll cover network connections and Wi-Fi in a further down tutorial. But this is the basics of that. So let me show you my last example. That's the real classical Unity example. There we go. I got this blue box and I got an on box and an off box. It's just like the rest of them, except these guys have triggers and they are made with Playmaker. So let's open the Playmaker editor. Off box over here is marked as a trigger. You can see it's right there. And it's right here just waiting for this player to collide with it. When the player collides, we're just going to use this function called send message. And right here you can see I have this method called LED off, but where does it come from? Well, the thing is, this box right down here, you can see it has the script directly pulled over on the object itself. And because they are public voids, you can interact with them directly inside Playmaker and, well, other software. So let's see the on box over here. Same thing, except it's using the LED on. And you can see we got all of these, but LED on is way down there. I'm going to hit play. I'm going to pull up my Arduino. And this one is using controls. It's just like a... You see it turned on. We're going to move over to the off. Oh, it didn't turn off. There we go. It turned off. That's because I have a delay built in. It's back on. Back off. You see, it didn't turn on. There we go. Turned on. Turned off. That's it. It's that simple. Arduino, Unity, Visual Studio, anything really want. Works like this. And that means you can develop something with your Arduino as hardware. And you can now use Unity or Visual Studio to control your hardware. I might go over a tutorial where we show you how to make a interface, PC interface using Windows standard look, so you get this Windows feeling. Let's see, I think I got a program running on the desktop. Yeah, here we go. I got this UDP sender. Looks like a normal window, except it's blue. Got the close button. I can input things and I can send. I'll save that for another tutorial. Thank you for watching. Comment, rate, subscribe, and I'll see you next time. And oh, there we go.